Okay, this is a quick go through of this 2021 paper. I used it as a practice mock for year 11, and here are my answers. So the actual exam was taken in 2021, which would have been during COVID. It's the regional paper, it's the double award science paper, which is also the first physics paper for those doing separate science GCSE, IGCSE. So it's Edexcel. Okay, this is the formula sheet that you're given with paper 1. The first question, I actually gave 2 of the answers because I gave them a nucleus splitting due to fission comes from a nuclear energy store, because we haven't done radioactivity yet. We've done the first 6 topics, so that means we haven't done nuclear or radioactivity, and we haven't done astrophysics. So it's all the questions other than those 2 topics. So this first question is mainly from topic 4, which is energy. And they're giving you one of them, and you've got to draw lines between the situations and the correct energy store. So you'll see I've drawn them in green. It says 1 for getting the elastic one right, 1 for getting the kinetic one right, and 1 for gravitational. And each of these is which energy store that decreases for the situation given on the left. Most people got these correct in the papers that I marked. The next question is about energy transfers rather than energy stores. So energy is transferred when a filament lamp is connected to a battery. So the battery has chemical energy store, and the filament lamp gives out light radiation. But what is the mechanism by which the chemical store changes into light? Well, the mechanism is electricity. So we say the energy transfer is electrical. You can also say that electrical work has been done. Okay? Whenever a charge moves due to an electric field, or like a battery, then we say electrical work has been done. Okay? Next question is, which method of energy transfer takes place between the lamp and the surroundings? Well, the lamp is gets hot, so it has a thermal store, and then it radiates light because of it gets glowing hot, in other words, so it becomes white hot. So the light radiates to the surroundings. So the method of energy transfer between the lamp and its surroundings is the radiation of light. Okay, so that's another form of energy transfer. Okay, so that's a quick starter for 6 marks. Actually, it was 5 marks. So because we had one of them already taken off. The next question is on waves. And it's showing dispersion. So you can see a prism, the light coming in from the sun, it disperses into red, green and violet, so all the colors of the rainbow in between. And on the outside of the red, P represents infrared, and on the left side, if you like, depending on which way you're looking at it as the light's coming in, the top of the least dispersed light P will be infrared. The most dispersed, if you like, from its original, or deviated from its original direction, will be T, which will be ultraviolet. Okay, complete the table to show the missing parts, and there you go. So I put green as the color in between red and violet, but any color between red and violet could be yellow, green, or blue between the violet, so it's the colors of rainbow. And on the outside will be infrared for P and ultraviolet for T. Note, it says electromagnetic energy or radiation transfers energy to the thermometers, which increases their thermal energy store. Okay, so you see the diagram, that's where they put thermometers, okay, because they're going to ask you a question about that later. And it says, suggest why the lower part of each thermometer should be painted black. Well, the bulb of the thermometer. The lower part is where the liquid which expands is contained. So used to use mercury, and now they tend to use alcohol, okay, it's coloured alcohol. So black is a good absorber of radiation. So 1 mark for knowing that black absorbs radiation, and 1 mark for knowing that black is basically the best absorber of radiation. And also, in other questions, it would also be the best emitter of radiation. Okay, so C says the equipment is left for a short period of time. The thermometers now show higher temperatures than before. They will all gain some increase in temperature, yeah, because time creates the energy transfer to the thermometer from all of the different parts of the spectrum. But it says state which part of the spectrum, yeah, the part of the electromagnetic spectrum in this demonstration, the ones that we've looked at, that would give the largest temperature increase, and that's infrared, because infrared is basically electromagnetic radiation which produces heat the most. So when you're out in the sun, what makes you hot is infrared radiation, okay? And it can also lead to burns, skin burns. Whereas ultraviolet is more to do with tanning and creates a chemical reaction in the skin which darkens the skin. So that's the second question, waves topic. The next question is astrophysics. So I haven't gone through it with my students, but for the answers, a circular orbit around a star would be a planet, and an elliptical orbit around the star, which is Y, would be a comet. They want you to know the difference between more circular orbits and more elliptical orbits. Then it goes into object X completes an orbit of the star in 35 days. Well, 35 days, you've got to work it out in seconds, so that will be multiplied by 24 to get it in days, multiplied by 60 to get it in minutes, and another 60 to get it in seconds. So 1 mark for being able to work out the time period in seconds. And then they say the radius of the orbit is 1.5 times 10 to the 11 meters. So they've given you two significant figures, the distance of the radius there, but for speed, it does a complete circumference of the orbits, therefore it would be 2 pi r, the distance traveled. So you've got to put the numbers in, do the maths, and divide by the time in seconds, and you'll get 311,666 meters per second or thereabouts. That's the calculator value, but that will give you 6 significant figures. But remember, the only information they're giving you is accurate to 2 significant figures, so you need to round it up to 310,000 meters per second to be correct in terms of how accurately you know the speed. Okay? So this equation, 2 pi r over period, is orbital speed, is given in the formula sheet if you look back at the earlier part of the video. Question 4 is then from the area 11 topic that was studied by my students, was solids, liquids and gases, and this is investigating how the pressure of a gas varies with temperature. So I've done this experiment with students before where you can actually get the results if you do it well. So the gas is a fixed amount of gas and a fixed volume, so those are controlled variables, and you gradually heat it in a water bath, which is heated usually with a Bunsen burner, and then you've got a pressure gauge as well. So in this case it's a pressure sensor, and it's going to a data logger, okay? But you can also do it with a normal analog pressure gauge called a Bourdon gauge, okay? So the volume of the gas is kept constant. That's the control variable. The volume of the gas is a controlled variable. They've told you that. So I had already written it out before I read the next sentence. It then says, state why it is important to keep a controlled variable constant throughout the investigation. But it's there to make it a valid experiment. If you change more than one variable, more than just your independent variable, if there's 2 variables changing, you won't know what is the cause of the change in the dependent variable. And we want to see how temperature affects the pressure, so everything else must be kept constant. Okay, so that's called making it a valid experiment, that you are actually finding out what you aimed to find out. Okay. Then they give you the results. All the results are between 0 and 100 degrees centigrade, or more likely room temperature and 100 degrees centigrade. And if you then draw the line backwards, you'll see that it hits the x-axis at minus 300. Okay, so that's something to look at the later part of the question. It says, explain how these results show that there is a linear but not directly proportional relationship. They said not proportional. I always tell my students it's directly proportional. Okay, and now we've got to explain what's the difference between linear and directly proportional. And obviously it's between the pressure of the gas and the temperature of the gas on the two axes. So it's linear because it's a straight line. That's all you've got to say. It's a straight line, but it's not directly proportional. I put directly in brackets because they haven't used directly, because it doesn't go through the origin. Okay, so for it to be directly proportional, it must go through the origin, and that's why you normally would be expected to change the temperature into Kelvin, and then it would then be going through the origin at absolute zero. Okay, so use the graph to determine the value for absolute zero. Well, in this graph, when you show your line on the graph, you get 1 mark. So I get 1 for drawing the line on the graph the way I have, and 1 mark for not cheating. They don't want you to pretend that it's going to minus 273. They want you to draw the line all the way through and seeing where it comes out. And it comes out just below minus 300. Okay? So that's how you get the 2 marks for extrapolating, it's called, the line backwards all the way until it reads at what temperature the pressure will be 0. Okay? I've done it with students and they have got quite close to 270 or 280 degrees, so it can be done quite accurately as a class experiment. It then says explain how the pressure of the gas changes as its temperature increases, and you have to include ideas about particles in your answer. Okay? They don't want a mathematical answer, they want the conceptual understanding of the particle theory of pressure and temperature. So any of these points, 3 of them, will get you the 3 marks. So an increase in temperature increases speed or kinetic energy of particles, 1 mark. And then this increase in speed causes more frequent collisions between the particles and the container walls. So more frequent means more collisions per second, so that's another way of saying it. But you do need to say, you can't just say more collisions. Okay, more collisions in a unit time and unit per second. And then collisions at higher speed are also harder or more forceful. There's a greater force involved. So as long as you get the point across, you get another mark. And remember, the total force on the container wall therefore increases because all of the molecules or all the particles are striking the wall with greater force, and we need to know that pressure is force per unit area. So that's another way of getting the marks. So it depends on how you've put your ideas in a logical sequence and clearly explain it. So remember, depth, detail, clarity is what gets you the marks. Okay. The next question is mathematical, and they want you to use the pressure law. The pressure of the gas at the beginning is 112 kilopascals, so that's P1, when its temperature is 35 degrees centigrade. Now you've got to change for the pressure law. You can't use Celsius. You have to change it into Kelvin. So 35 Celsius is 308 Kelvin, as shown in the box to the right. The gas is then heated to 340 degrees centigrade, so that's temperature 2. Temperature 2 then is 340 plus 273, which is 613 Kelvin, and they want you to calculate pressure of the gas when it's been heated to 340 degrees centigrade. So it's P2 over T2 is how I put it, equals P1 over T1. Yeah, I think this equation is given to you on the formula sheet if you look back. And then I've changed the subject to make it just P2 by multiplying both sides by T2. You will see, then you put the numbers in, you'll get the answer as I've shown it. Okay, hope it makes sense to you. So that to 4 significant figures, 1 decimal place gives you 222.9. So 223 to 3 significant figures, but you should only include 2 probably. I would accept 3 because they've given the initial pressure as 112 kilopascals, which is 3 significant figures. So maybe the best way is to include 3 significant figures in your answer. Okay? And then it says the volume of the gas is constant in this investigation. Yeah? Name the other quantity other than volume which is kept constant, and that's the amount of gas. So we've got a fixed amount of gas as well, which must be kept constant. So those are the two controlled variables. Okay, that's a 13-mark question from a recent topic done, and it's a big question. Next question is from topic 1, forces in motion. They've given you a velocity time graph where it's accelerating, then going at constant velocity of 4.3 if you read it carefully, and then it decelerates quite quickly in 0.05 seconds. So you need to make sure you read the time correctly. And the first question says calculate the distance traveled by the car during the first 0.4 seconds, so before it decelerates. Now, the distance traveled from a velocity time graph is the shaded area. It's the area under the graph. So there's an area of a triangle and an area of a rectangle, and you've got to work them both out. So the area under the graph for the triangle would be half of the maximum speed times the time, which is 0.2 seconds. That gives you 0.43. And obviously the rectangle is twice the area of the triangle, so it would just be constant speed times the time taken, which is 0.86. Add them up, you get 1.29. One for knowing is the area under the graph, one for doing the triangle area, one for doing the rectangle area, and one for getting the final answer correct. Okay. Then it says calculate the acceleration of the car between 0.40 seconds and 0.45 seconds, and a couple of students put that down as the time difference of 0.5 seconds. So obviously it's 0.05, so be careful with that. And it's a negative gradient, so it'll be the final velocity is 0, and the initial velocity is 4.3. So 0 minus 4.3, which will give you an answer of minus 86 meters per second squared. So the acceleration is the gradient, whereas the distance was the area under the graph, and that's how you do the question. So you're given the data on the right. V is 0, U is 4.3, and T is 0.05. Okay, the next one, it's Newton's second law. State the formula linking resultant force, mass, and acceleration. So I've got it as symbols, but I've shown which words are linked to which symbol, so there's no confusion for the examiner. That's a good way of doing it, in a way, to make sure that you know which words are linked to which symbol, rather than spending time writing it out again as a word equation, which is in fact the correct way of defining any quantity in physics. The car has a mass of 0.13 kilograms, so it must be a toy car, yes, and calculate the resultant force. So you know the mass and you know the acceleration from part B1, 86, multiplied together, and to four significant figures, 11.18, but really you only have data accurate to two significant figures, so you can round it up to 11 newtons. They've given you the unit. And then it says a piece of soft material is fixed to the front of the toy car. Explain how this will affect the gradient of the velocity time graph. So that's like having a bumper rather than, or a soft thing that you collide with, like a bit of sponge if it's a toy car. So obviously that is increases the time taken for the collision. So by putting something soft, it will actually soften the blow itself. So you increase the time of the collision. If you increase the time of the collision, you reduce the force of the collision, because this is a question of impulse equals change in momentum, and change in momentum over unit time would be a deceleration. Okay, so mathematically, if you want to write this, this is equal to F times T, yeah, is equal to change in momentum. That symbol means change in momentum, yes? So the acceleration will be smaller because the time is increased. Now, if the time goes up, then the force goes down, because the total change in momentum will still come to rest, yeah? It just comes to rest a little more gradually. So acceleration will be less, therefore the gradient will be less steep. So it's 3 marks, but this is the maths that we're looking at, yeah? And this is impulse Ft is called impulse, is equal to the change of momentum, which is basically Newton's second law in terms of momentum. And originally, Newton said that force is equal to the rate of change of momentum, rather than, he didn't say force is equal to mass times acceleration. Okay, so this is a good question to revise your first topic from the beginning of the GCSE. Okay, the next question is on Snell's law. Snell's law is refraction. So they've got the ray of light going in from air. It then bends towards the normal. Yes? So remember, the normal is a dotted line. Yes? All angles in ray diagrams are drawn to that imaginary line perpendicular to the surface. Okay, so be warned, they will trick you sometimes. So you've got to measure this angle. Yeah? And I was surprised that many students couldn't measure it. So you do need to bring a protractor in to the exam with you. And all three people who've borrowed my protractors, I've got hardly any left in the physics lab. We used to have a stock of over 30 last year, and now we're down to the last few because students have taken them and haven't returned them. So you'll need to go and buy them before your mock exam. All right, so 17 degrees if you measure it according to the examiner. It says use a protractor to determine the angle of refraction. Yeah, I've called it R. Yes, and then they want you to state the formula to linking refractive index, the angle of incidence, and the angle of refraction. Well, it's the sine of the angle of incidence over the sine of the angle of refraction is equal to the refractive index, which is written as N. Okay? In GCSE, normally one of the materials will be air. So, and that has kind of doesn't really deviate light much at all. It's very, very slight compared to a vacuum. Okay, so then you divide the sine of 29, which was at the top, by the sine of the angle that you measured. And if you made a mistake, they will allow you to carry your error forward and still show that you know how to do it and get the marks. So if you do that, sine of 29 is 0.484 and sine of 17 is 0.292. Divide the two, you get approximately 1.7 to 2 significant figures. Okay, and that's another question done, just a 5 marker. Yeah. And the next question is back to solids, liquids, and gases. So this was a really good test for those people who did solids, liquids, and gases recently. And it's now talking about a glass that contains fizzy water. Fizzy water is basically carbonated water. Bubbles of carbon dioxide is how they carbonate it, form at the bottom of the glass and rise to the surface. Okay, why would they rise to the surface? It means that there must be a resultant force on the bubbles upwards. Okay, so think about that. So there is a bit of force involved in this question too. The graph shows a relationship between pressure and volume, where this is Boyle's law. Yeah, and Boyle's law is P1V1 equals P2V2. My students have done this graph, they've done the experiment, they've measured the pressure against the volume, they know they're inversely proportional. So the graph shows that relationship, and you need to now consider how to answer the question. Describe the relationship. As volume increases, pressure decreases. Yes, at a decreasing rate. Or you could say, yes, P and V are inversely proportional. That means if you double pressure, you halve the volume. Yeah, which it would replace saying at a decreasing rate, because obviously at a decreasing rate, as volume increases, the gradient decreases, and that's another way of saying it. Okay, but if you know that they're inversely proportional, that should get you both marks because you've understood it. Yeah, I would put this, and then I would put this. It might be easier than saying at a decreasing rate, especially if English is not your first language. And we have a few students who are learning physics in their non-native language, which makes it more challenging. It then says state the formula linking pressure difference, height, gravitational field strength, and density. So again, I've written the symbols, yes, and then I've drawn the line, an arrow to the symbols, so the examiner can't doubt that I know that H stands for height, G stands for gravitational field strength, rho stands for density, Greek letter, and P is pressure difference rather than pressure. Okay, and it's written P equals H rho G, very common. So the question that comes up is the depth of the fizzy water is in the glass, which is 22 centimeters. You've got to change that into meters, and the density is given to you for the fizzy water. Yeah, normal water will be 1,000 kilograms per meter cubed. This one is carbonated, so seems to be more dense than normal distilled water, say. Then it wants you to calculate it, so you just put the numbers in the equation that we just went through, and you'll get 2,376 if you put all of the 4 significant figures in, and then you can round it up because most of the data given is to 2 significant figures. I think 3 significant figures is fine too, because they've given the density to 1,080 kilograms per meter cubed. Okay, so 2 or 3 significant figures here would be suitable. And then remember, it says, remember that the pressure difference, yes, is the increase in pressure due to the liquid, but on top of the liquid is also atmospheric pressure. Okay, they've given you in the next question what atmospheric pressure is. It's always around 101,000 pascals or 101,000 newtons per square meter. So they want you to calculate the pressure of the gas in the bubble when the bubble is at the bottom of the glass. So the pressure of the gas is equal to the atmospheric pressure plus the pressure difference, which you just worked out, 2,400. So you add the 101,000 with the 2,400, and you'll get approximately 103,400. And again, you can round it up to 3 significant figures. Okay? So that's the next question. It then says, when a bubble at the top of the glass, when the bubble is at the top of the glass, I should say, the pressure of the gas in the bubble is equal to 101,000 pascals. So that's called pressure 1, the way I put it, and the volume was 0.084 centimeters cubed. So that would be volume 1. It wants you to calculate the volume of the gas in the bubble when the bubble is at the bottom of the glass. Well, at the bottom of the glass, pressure 2 was 103,000, yes, to 3 significant figures. So you now put all the numbers in. We know P1V1 equals P2V2. Then you've got to change the subject to make V2 what you want to find. Yes, remember we want to know what is V2, which is at the bottom of the glass. So V2 will be P1V1 divided by P2 to put V2, the subject of the equation, put the numbers in. And again, you can show 4 significant figures first, and then show that you know that you should be rounding it up to the equivalent of 2 significant figures, because the original volume was given to 2 significant figures. So again, 2 significant figures is what you should give here. Hope that makes sense. So you've had the pressure law and you've had the Boyle's law in this exam paper. So it's really good revision of what you just studied in year 11. The next one goes to the forces that that I mentioned before. The force upwards on the bubble is called upthrust, and it acts vertically upwards, so let's call that U. And then when the bubble is released, it accelerates vertically upwards. Yes, so if it's accelerating upwards, that means there must be an unbalanced force, and if there's an unbalanced force, it's Newton's second law, F equals ma. Yeah, so draw 2 labeled arrows on the diagram to show the forces on the bubble as it is released. Yes, so the upthrust is upwards, the weight is downwards, but the upthrust must be bigger than the weight to show that there is an unbalanced force or a resultant force. Remember, Newton's second law is always about there being a resultant force. Yeah, one is bigger than the other. And that's the end of that question. All right, the next one is on magnetism, which we've done very recently. Yeah, so this is drawing field lines. They want at least 4 field lines going from the poles, and they want you to show the directions, and they want at least 1 above and 1 below. And then you've got the directions, it must be north to south, so that gets you 3 marks. Easy 3 marks. And then they've got the second bit is about electromagnetic induction, which students found difficult to verbalize, having just studied it. So you need to learn how to do this, the language that you use for these questions. It says the diagram shows a loop of wire which is attached to a voltmeter. It's a sensitive voltmeter, because if it's just a loop of wire. And then it says explain why the voltmeter reading changes from 0 when the magnet is moved near the loop. Now remember, in electromagnetic electromagnetic induction, it doesn't matter what's moving. In this case, the magnet's moving. Yes? So the magnet's movement induces a voltage. That's why it was 0 at the beginning. When there's no movement, there'll be no effect on the wire. So the wire is a conductor, and inside the conductor there are free electrons. And the free electrons actually feel the magnet moving. And that's why they're pushed one way or another, and they're attracted to one side. And that's what creates the electrical effect, or induces a voltage or an EMF. So you could also call it an EMF. Okay? That's meant to say F. Let's see if I can fix that. So, EMF, so this would also be called an EMF, a voltage. A voltage is an EMF, or an electromotive force. Okay, when the magnetic field cuts through the wires, or cuts through the wire, a conductor, you can have a changing magnetic field. And a changing magnetic field is what you need to induce EMF. Yeah? So it's a changing magnetic field, or the best way of saying is the field cuts through the wire. Yeah? If the wire moved and the magnet didn't move, you still get the induced voltage, because it doesn't matter as long as there's relative motion between the conductor and the magnet, then the electrons will be pushed one way or the other, and therefore moving the needle either to the left or the right depending on the relative motion. So that's a good question for revising the latest topic. It does magnetism and it does electromagnetic induction. Okay. The next question is on topic 3, waves, and it's a way of putting your answers in a clear fashion, in a logical, coherent way. The diagram shows 2 students holding a piece of a string with a box attached. The box has a buzzer inside. One of my students whose first language is Russian said, "Oh, I don't know what a buzzer is." Yeah? So remember, if English is not your first language, you are allowed to take a dictionary and use it. A buzzer is something which buzzes. Yes, it's like a constant sound, which buzz. So the word buzz in buzzer means that it's buzzing. That's the noise it makes, like a zzz sound. Okay, so the buzzer in the box emits a sound of constant frequency. So even if you didn't know what a buzzer was, here they're explaining it. The buzzer emits a loud sound of constant frequency. Okay? So when the box moves away from student A, yeah, so student A is on the left at constant speed. So immediately I know this is the Doppler effect, yeah, which is a change in perceived frequency by the observer. Yeah, so the observer could be student A or student B, but they're asking, explain why the sound heard by student A has a different frequency to the sound emitted by the buzzer. So if you're standing next to the buzzer and the buzzer isn't moving, it will give one frequency. If the sound source is moving away from you, it gives a different frequency. And if the sound source is moving towards you, as with student B, it will give you a different sound frequency as well. Okay, so the Doppler effect is a change in the perceived frequency by the observer depending on the relative motion of the sound source. Okay, so the first way of doing it is to say waves or wave fronts are emitted at constant frequency from the sound source, 1 mark. Doppler effect itself will give you another mark, so that's 2 already, you want 5. And then the wave fronts arrive at student A further apart because the buzzer is moving away. So what happens is the sound waves get stretched, yeah, as they're moving further apart, as they're moving away from student A, so that they become stretched, in other words, due to the motion of the box away from student A, yeah? And the distance between the waves, or the wave fronts, is the wavelength. So the wavelength becomes longer. So the wavelength goes up, increases, yeah? And since speed is frequency times wavelength, and the speed of the waves is constant, because this is speed in air, then we know that if the speed is constant, if the wavelengths get longer, the frequency must get shorter or lower. The frequency must decrease, okay? So the frequency decreases because the wavelengths are longer as perceived by the observer, student A. So the sound heard by student A will be a lower frequency than the original pitch of the buzzer, okay? Any of these bullet points will allow you to get the 5 points listed. So here there are 3, 6, 7, 8 ways of getting the 5 marks, okay? So again, these kind of questions, you've got to get your English very clear. You've got to give the full detail. You've got to use the correct key words like wave fronts, yes, or wavelength, yeah, and talk about it being stretched or compressed in the direction as perceived by the observer. If it's coming towards it, it gets compressed. As it's moving away, it gets stretched, okay? And that was the last question in the 1 hour practice exam that we gave, but I'm going to go through the rest of it as well for people who are revising. Question 10 was about uranium, which is nuclear physics, or radioactivity, yes. So topic 7. So this is a nuclear fission reaction where uranium is hit by a neutron, and that's how they actually did this experiment. They just discovered the neutron in 1932, and they thought, well, I wonder what happens if we fire a neutron at an unstable uranium atom, and then they noticed that it split into two daughter nuclei, and the 235 neutrons and protons inside the uranium are then 97 go in the zirconium in this case, and 135 are left in the tellurium. I think that's what they are. And then what's missing? Well, if you do it carefully, you'll find that the total number on the left was 236, and then if you add the 97 with the 135, that's all the particles. 97 and 135 is 232, so we have 4 neutrons left. So they want you to work out how many neutrons are there here. In other words, X must be 4, yeah? And the bottom number, by the way, is the charge. And we didn't need to deal with that. So the bottom number is the protons, the top number is the total number of protons and neutrons, and the left-hand side numbers must equal the right-hand side numbers, okay? That's how you work it out. So it's balancing a nuclear equation, which is a lot easier than balancing a chemical equation. Okay, describe what is meant by a chain reaction. Chain reaction is when neutrons are released. So in this case, 4 neutrons released. Then each of the released neutrons can then be captured by another uranium nucleus, yes, or by other uranium nuclei. Nuclei is the plural of nucleus, yes. So you can have 4 more uranium atoms undergoing fission, and then these nuclei can also then create a chain reaction by the next layer happening. So it depends on having enough uranium in the place, and that's, if it goes out of control, it becomes an explosion because the energy cannot be contained in the material. And that's what a nuclear bomb, that's a design of a possible nuclear bomb. Okay, so 3 marks for the 3 bullet points as listed. It then says iodine is an isotope found in radioactive waste, iodine-129. So you need to know what isotopes are from nuclear power stations. So this is a waste product from nuclear power stations, and it has a half-life of approximately 15 million years. That means every 15 million years, the number of atoms of the isotope will go down to half of the original number. So, and that also means that it's less active, so the activity goes down. So the original activity was 72 kilobecquerels, so 72 units kilobecquerels. That would be 72,000 if you had to define what kilobecquerels was, but you can leave it in 72 kilobecquerels, and it wants you to show that the time required for the sample to go down to an activity less than 5 kilobecquerels is approximately 60 million years. So 60 million years is 4 of these, 4 half-lives we call them. So let's see, so in half-life, in 15 million years, it will go down to 36. In 30 million years, it will halve again, go down to 18. In 45 million years, it will go down to 9. Yes. And in another 15 million, which is 60 total, it will go down to 4.5. That says 4.5, not 45. Okay? So it takes 4 half-lives for the activity to decrease to less than 5 kilobecquerels. So that they want you to do it in number of half-lives, which is 60 million years. Okay? So it's quite a long half-life. So this is a problem with nuclear waste. It stays around for a long time. And if you've got a lot of concentrated waste in one place, then the storage of it is an environmental issue. So the same radioactive waste from nuclear power station, some radioactive waste from nuclear power station, I should say, has a very long half-life. Discuss precautions that must be taken when disposing of this waste. Yes, well, you've got to place the waste in sealed containers that I would put, this is how I would verbalize it, that will last a long time, because you don't, obviously your containers must be long lasting so that it doesn't leak out and go into the environment, okay, wherever you put it. Containers must be made of materials that don't corrode, for example, or rust or leak, yes? So obviously all of those things affect each other. Corrode is general, rust is with iron. Rust-proof containers are expensive or difficult to manufacture, yeah? So I don't know, that's not a precaution, but they're given that as a mark. So it must have been when they read some sample answers that students are given, yes? They're asking for precautions. So if they're talking about expense, that's not a precaution, it's a downside, yeah? So I think they become a little bit wishy-washy in their mark scheme. Then the containers or the waste should be buried, I've put here, in a safe, secure, low earthquake zone or site. So this is all the depth and detail that you could put to make sure the examiner is impressed with your answer. So there's 4 bullet points already. You can get 5 marks for this question. So for example, here's one I've given you. In Japan, after Fukushima in 2011, yes, which happened actually on my birthday, they have been diluting some of their nuclear waste from the problem that they had with the tsunami in seawater. So they're basically, the Pacific Ocean is so large, they think if they dilute it in seawater, it will not be so dangerous as keeping it all concentrated in one place. Maybe that's good. I'm sure the fish would disagree with you. Yeah. It then says it's essential to prevent the waste leaking into the water table. Now, the water table, rather than the seawater, is where we get our drinking water from. So the worst thing is if it goes into the drinking water. So again, the fish may disagree because the seawater is their drinking water. But if it's dispersed, it's the radiation spread over a very large area or a very big volume, then it will be more like it was in nature, because radioactivity is natural and it actually is in the environment anyway, but it's just not in a concentrated form. So that's any of those 5 from the list above. Question 11 is then, which we didn't use in our test, is used from topic 4, but it also involves forces because you're pushing a block up a ramp to lift it a height to put it on a shelf. So a ramp is a kind of very simple machine which gives you a mechanical advantage of some kind. Okay, so they want to link the equation that links work done, force and distance. So I forgot to show that force, so you could have used the symbols, but this time I wrote the word equation out and I'll get 1 mark for that. Once you've got that, student pulls the block 0.89 meters is in the direction of the force, yes. So there must be the work done, the force and the distance must be in the same direction. Yes? So remember, it must be moved in the direction of the force and up the slope. They've measured the distance up the slope, which is a direction that you're pushing the block up or pulling it up. So you multiply the 26 by the 0.89, you get the work done in pushing it, which is roughly 23 joules to two significant figures. Okay. They've then given you some more data. The block has a mass of 1.3 kilograms, so M is 1.3, and it moves vertically upwards 0.11. Yes, so that means it gains potential energy. The height gain, delta H, is a way of putting difference in height. Calculate the increase in the gravitational potential energy. So the increase in the gravitational potential energy, again, delta means change in height, produces a change or an increase in gravitational potential energy. The weight is 1.3 times 10 mg times the height gain 0.11. Put the numbers in to two significant figures is 1.4 joules, and you can see what it is to three significant figures. And that's the question on work done and potential energy gained. Explain why the work done to move the block along the ramp is greater than the increase in the gravitational potential energy store. Yeah, so the useful energy output is the gravitational potential energy, but because as well as working against gravity, there will be some friction, and you also have to do work against the friction. So you have to overcome the friction. So there's two lots of work. One is against lifting, against gravity, and one is against the friction forces. Okay, this transfers thermal energy to the surroundings, or it could be to the air, the ramp, so because friction causes heating in a general sense. But it's the bits outside the bracket which are crucial. Okay. It then says the student suggests it's better to use a less steep ramp to raise the block through the same vertical well. Discuss the advantages and a disadvantage. Okay, so the discuss an advantage. So discuss an advantage. So they want you to discuss it, not just state it. That means you've got to put more detail than just stating it. So from this, it says a lower force would need to be applied. Yeah, to overcome the friction to prevent the block from slipping down to move the block. Okay. A lower force would be needed. That would be an advantage. And disadvantage could be any of these. Using a less steep ramp would make the distance longer. So although you get the advantage of a lower force, you've got to apply that force for a larger distance, okay, to gain the same height. And then you could say that will make it less efficient. And you could end up doing more work in total, because remember, work is force times distance. And a greater proportion of the energy could be then transferred to the surroundings, so it becomes more wasteful. So that's how they've marked it, okay? So the level of discussion, how clearly you put the depth and detail in, will determine how many marks you get. So there's 5 ways of getting 4 marks, the way I've written it. The next question is electricity, topic 2. So the diagram shows some apparatus used to find the mass of an object. You basically got an electrical circuit here between a cell, a resistor, yeah. So you've got a cell, a resistor, a wire connecting to a piece of metal foil. The metal foil then touches the other metal foil, goes through the wire to an ammeter, back to the cell. So that's your complete circuit. And then you've got to work out what's happening. So 2 pieces of metal foil act as a variable resistor, yeah? Because when the metal foil moves, because it's being pulled by the pulley, or by the mass over the pulley, then it will change how much of the metal foil the electricity needs to go through, okay? So the more mass is added, the elastic string, yes, they've drawn the elastic string, will pull this small piece of the metal foil above it. It will move to the right, yeah? So it's going to pull the top bit sitting on the metal foil to the right. And that means in this section here, the length of the metal foil that the electricity the current needs to go through becomes longer. So if it has to go through more of the foil, you're actually increasing the circuit in terms of length of wire, length of foil, therefore you're increasing the resistance. Okay? Hope that makes sense. The metal foil moves to the right, greater mass, therefore the resistance to the circuit will increase. That's without answering any questions. That's the understanding that I gain from looking at the diagram. Then it says draw the circuit diagram for this. Okay, so the variable resistor is the metal foil. They're giving you that, and then you've got to put the ammeter, the cell, and the fixed resistor in series. And if you put the circuit symbols correctly for each one, you get 1 mark for each symbol, and all in series, the 4th mark. The voltmeter comes to from the next question. They haven't asked you to draw a voltmeter in yet. It then says draw a voltmeter on the diagram to measure the voltage across the variable resistor. Correct symbol, yeah, gets you 1 mark. In parallel with the variable resistor gets you the 2nd mark. And then says explain how the voltage across the variable resistor changes if more mass is added to the end of the elastic string. So if you add more mass, yes, it will increase the resistance, as I explained to you before, as the current will have to go through a longer strip of metal foil. And longer means more resistance, and resistance of the metal foil is the resistance of that bit itself is directly proportional to the length of the foil that it has to go through. Okay, so any of these arrow-headed points can gain you marks. So that's 1. More mass, more resistance. Total resistance circuit will increase. That's more detail. So current will decrease, yes, because obviously we haven't changed the voltage. The voltage across the fixed resistor will decrease as a result because the share of its voltage will be now smaller because the total resistance is greater, and the total voltage in the circuit hasn't changed. The cell's still giving the same voltage out. So the voltage across the variable resistor, in conclusion, will increase. Okay? So there's 5 or 6 ways to get these 4 marks. So there's an electricity question. They then give you data of voltage against current in milliamps, voltage in volts. Yeah. So remember, milliamps is 10 to the minus 3. You have to be careful in GCSE that you do read these prefixes in front of the units accurately and know what they mean. Okay. So that's some good revision skills for you to carry out during your winter break before your mocks. State the independent variable. The independent variable is usually the first thing in a table. It's the thing that you control, you change, you vary, and that's the voltage. Okay, when you change the voltage, it changes the current. So in other words, the voltage controls the current depends on the voltage, so the current is the dependent variable. Plot the results on the grid that they're given you, and you've got to choose a sensible grid, sensible scale, use at least 50% of the grid that they provided. Draw, and then they want you to plot it. Axes must be labelled with quantities and units for 1 mark, and so this is how you get 3 marks. And accurate plotting, all points must be plotted accurately to get a 3rd mark, and then you draw your line of best fit for the 4th mark on the graph. So I took these and I put voltage as the independent variable on the y-axis, and I can't use all the squares the way it's done. If I want a sensible scale, I'm going up in 2s, and I always tell my students go up in 1s, or in fact multiples of 1, 2, 5, or that's it. Don't use any other number because it's easier to plot. And you can see the points I've plotted are pluses, not dots. Always use pluses, so when you draw the line of best fit, it doesn't hide the points that you've plotted. So always use pluses, don't use x's, don't use dots, okay? And you've labelled both axes, that's how you get it. And that's the end of the 110 marks, and that's what your mock will be like in January. 110 marks, 2 hours to do it in, and I don't know how long it's taken me to do this video, but I'm now going to, if you found it useful, share it, like it, share it with any friends who are doing GCSE revising for the mocks, and like it to show your appreciation for all the videos, and leave a comment if you have any questions, suggestions for future videos, etc. I'll try and do as many as I can. So I'm doing this in the evening after a full day's work. So I appreciate all the positive feedback I get. And we need subscribers. I want to get to 1,000 subscribers before you finish your GCSEs. So thanks again, and catch you in the next video. Bye for now.